Hi, so today I'm going to be doing the ferroliquid ferrofluid experiment. So I already have my ink poured in just because I wanted to do that like in the sink, like kind of just, very carefully because it is ink. I got my oil. So my mom said we had vegetable oil, we had canola oil. I know for like cooking, it doesn't like really matter which one it is, so I'm kind of hoping it's the same case here. And I'm gonna add one tablespoon of this. Okay, and I'm gonna mix it and then see if it needs more to make it thinner. So while I'm mixing it, I'm just gonna kind of explain what's going on here. So a ferrofluid liquid is a liquid that's super highly magnetized, and it's known as something called a it's COLLOIDAL fluid. I'm having trouble pronouncing it apparently. But yeah, so so this is composed of nanofluid ferromagnetic particles that are suspended in a carrier fluid, and in this case the carrier fluid is going to be the canola oil, and coated with a surface tint to stop them from clumping together in the liquid. So that's the surfactant makes it a liquid, like kind of keeps it being a liquid. So essentially, for the most part, this whole thing is composed of 5% magnetic particles, 10% surfactant, and then 85% carrier fluid. So with the reaction that you are going to see very shortly, the carrier fluid, so the distinct, so I'm going to transfer it to another thing now. So here we go. Okay, and the spiky stuff that you see is caused by the need for the ferrofluid to find the most stable shape in order to minimize total energy in the system. This effect is known as the normal field of instability. And essentially the fluid is easily more magnetized than the surrounding air. So that's how this kind of all happens. And so essentially it results in the peaks of when it meets the magnet, the rare earth metal magnet. So the formation of this lowers the magnetic energy of the system, but raises the gravitational energy and surface free energy. When the forces are balanced, the minimum energy configuration is achieved. And because ferrofluids are easily magneticized, the spikes can be produced under even a very small bar magnet. So now I'm going to see if I can get this to work. Oh wait, I'm scared to move this closer because I don't want to spill this black ink. But I'm starting to see a little bit of spikes, but not nearly as much as there was in the video. Hello, Owen. Yeah, there's just not as many spikes as I thought there would be. And I mean, when I'm holding it on the bottom, nothing's really happening, but when I'm doing it on the side, I can see a little more action happening. It's like the tiniest bit of spikes, not nearly. I feel like me having it sit here for a little longer is not going to change anything. So, though my reaction did occur, my experiment was successful. It wasn't as successful as the demo video that was originally there. This might be because
Boomer's coming up.
I used, oh, make sure he doesn't come over here. This might be because I used canola oil instead of vegetable oil, and so on and so forth. But yeah, so that's this experiment. There's a dog up here on the ledge, so I want to get down before he knocks the ink over. But yeah, thank you.